Hello friends, welcome to Learner's Planet. Friends, this is our 8th session for progression and series. We have discussed so many problems, concepts based on arithmetic and geometric progression. Let's take some more concepts, some more problems based on progression and series. And in this session, we'll be discussing arithmetic geometric progression also. Okay, so let's begin this session and just get ready with your paper and pen. Now, we have arithmetic geometric progression. Now what exactly an arithmetic geometric progression is? See, here you can see I have given a question that is sum of infinity of the series. That means we have to find out the sum till infinity of the series. In this series you can see 1, 2, 3, 4. All of these are in arithmetic progression, and x square, x cube, these are in geometric progression. So we call these sort of sequences as or series as arithmetic geometric series. Okay, so one part is in arithmetic progression and other part is in geometric progression. Now how do we find out the sum till infinity of these sort of series, or maybe sum till sum of n terms? Okay, so in this case precisely we are finding out the sum of this series till infinity. Okay, and here it's already given that modulus of x is less than 1. That means the common ratio is less than 1. That's pretty clear, because we will not be able to find out the sum till infinity if x is, or the common ratio is, more than 1. Okay, that is a preliminary condition. Now how do we find out the sum till infinity? Okay, now here s I assume 1 plus 2x plus 3x square plus 4x cube and so on. This is what is s. Now once again I write s. In this case what I do, I just move one step ahead. I'll start writing 1 from this step. Okay, so it is 1 plus 2x plus 3x square and so on. Since there are infinite terms, no need to worry about the n term. Okay, now what I do, I multiply this entire sequence by x, both the sides. So sx is equal to x plus 2x square plus 3x cube plus 4x4 and so on. Now you see this and this. Okay, what I do, I deduct this from this or this from this, right? So s minus sx. 1 will be as it is, plus 2x minus x, 3x square minus 2x square, x square, 4x cube minus 3x cube, x cube, and so on. Now you see, we have got absolute geometric progression over here by this way. Okay, now that has become very simple for us. It is s1 minus x is equal to the sum of a geometric progression is first term upon 1 minus common ratio, right? So s is equal to 1 upon 1 minus x whole square. And what was s? S was the sum of this series. And what is s? 1 upon 1 minus x whole square. That means this series, the sum of this series till infinity is 1 upon 1 minus x whole square. So this is how we can solve an arithmetico-geometrico series which have the number of terms till infinity. Okay, now see this. If the sum to infinity of the series this is 9 by 4, find r. The same way we'll proceed. I assume this to be s, so s is equal to 1 plus 2r plus 3r square plus 4r cube and so on, right? The next step is I multiply both the sides by r. So SR is equal to R plus 2R square plus 3R cube. Okay, now deduct this from this. So S 1 minus R is equal to 1 plus R square plus R cube and so on. So S1 minus R is equal to sum of the sequence that is an infinite geometric progression with common ratio r, so that is a upon 1 minus r. Okay, first term by 1 minus common ratio. So precisely s is equal to 1 minus 1 upon 1 minus r whole square, and that is actually 9 by 4. Okay, so this is 3 by 2 whole square. So 1 upon 1 minus r is equal to 3 by 2, or 1 upon 1 minus r is equal to minus 3 by 2. So if you solve, you'll be getting two values of r. If both of them are less than 1, then both the values are acceptable. If one is less than 1 and other is more than 1, then it is not acceptable. Okay, so here 1 minus r is equal to 2 by 3, so r is equal to 1 by 3. So this is the favorable value. Similarly, 1 minus r is equal to minus 2 by 3, so r is equal to 5 by 3. Okay, 1 plus 2 by 3. So this value is not acceptable, because if it is an infinite geometric progression, the value of r has to be less than 1. That means the common ratio has to be less than 1. So it is not acceptable. Okay, so what will be the comfortable value or the favorable value of r? That is 1 by 3. Okay, so how simply you can solve this sort of problems, you see. Now we will find the sum of n terms of an arithmetic geometric progression. For that you need to learn the three formula that I am writing over here. Sigma n, that means sum of first n natural numbers, that is n plus 1 by 2. Right, first sum of first n natural numbers is n plus 1 by 2. Sigma n square is equal to, that means sum of squares of first n natural numbers, right? So that is n plus 1, 2n plus 1 by 6. This is what? 1 plus 2, 3 till n. This is 1 square plus 2 square plus 3 square till n square. Similarly, sigma n cube, that is n plus 1 by 2 whole square. That is actually 1 cube plus 2 cube till n cube. So these three formulae you need to learn. Okay. Now find the sum of this series 2 square plus 4 square till 2n square. You can see all the numbers are even numbers over here, right? So what we can do is sum is equal to 2 square plus 4 square plus 6 square till 2n square. If I take 2 square as common, what I'll be getting? 1 square plus 2 square plus 3 square till n square, right? So that is the expression I'll be getting, right? I am taking 2 square as common. So this is actually 2 square into 2 square, that is 2 square into 3 square. Similarly, it is 2 square into n square. So if I take 2 square as common, I'll be getting this expression. Now 1 square plus 2 square plus 3 square till n square, we already know the formula. That is n plus 1, 2n plus 1 by 6. So I put up the value. S is equal to 4 n plus 1, 2n plus 1 by 6. So it is 2n plus 1, 2n plus 1 by 3. That will be the sum of this series. Sum of this series means if you put up the value of n as 1, you will be getting the first term. If you put the value of n as 2, you will be getting the sum of 2 terms. If you put n is equal to 3, you will be getting the sum of 3 terms. Okay? So that's pretty simple. Now this is going to be something different, and just listen to me carefully and see the explanation carefully. In fact, in these sort of cases, see 3 dot means into, this is into over here, 3 into 8 plus 6 into 11 plus 9 into 14 till n terms. So when we have to find out the sum of these sort of series, what we do, we try to find out the nth term first, right? Now how do we find out the nth term? You can see the first term is 3, 6, 9. That means the first terms are multiple of 3, right? So if I put 3n, it is justified. Okay. Now the second term is what? In terms of n, we have to find out the relation between this and this. Now how do I get 8 if I put n is equal to 1 and add 5, right? So this is actually the nth term. If I put n is equal to 1, I'll be getting 3 over here, and if I put n is equal to 1, I'll be getting 8 over here, right? So 3n into 3n plus 5 is the nth term of the sequence. You can verify it. If you put n is equal to 2, then you'll be getting 6 into 6 plus 5, 11. Okay, so how do you get this expression, this nth term? Just 8, 11, 14. Just find out the nth term of the sequence. So nth term will be what? See, common difference is 3. So nth term will be what? A plus n minus 1 into d. So 8 plus 3n minus 3. So 3n plus 5. Right? So the nth term of 369 is 3n, and nth term of 8, 11, 14 is 3n plus 5, because 8, 11 and 14, these are in arithmetic progression. So this is what the nth term of the sequence, right? So I assume this to be s. So s is equal to, I just open it up, 9n square. This is not s, actually this is the nth term, right? So nth term is 9n square plus 15n. Now you got the nth term. When you have to find out the sum, what you do? You do the summation of the terms. Okay, so sum is equal to sigma 9n square plus sigma 15n. Okay, so if nth term is given, you can find out the sum by taking sigma of the terms, okay, of the expression, I can say. Now what is sigma n square? When there is a constant, you just take the constant outside the sigma. So it is 9 sigma n square plus 15 sigma n. Now sigma n square is what? That we have already seen. Sigma n square is n plus 1, 2n plus 1 by 6. And sigma n is n plus 1 by 2. Okay, so we just put the value over here. 9 into n plus 1, 2 n plus 1 by 6. So that is 9 sigma n square plus 15 into n plus 1 by 2. That is 15 sigma n. So if nth term is given, directly you can find out the sum by taking the summation. Okay, sigma is nothing but the summation. So if you want the terms having 9n square, you wish to find out the sum, then you can write sigma 9n square. Now if you put n is equal to 1, you'll be getting the first term. If you put n is equal to 2, you'll be getting the sum of two terms over here. Okay, now it can be simplified further. 3 3s are 9, 3 2s are 6. So you can see n plus 1 by 2 is common. So n plus 1 by 2 is common. Then we are left with 3 times 2n plus 1. 3 into 2n, that is 6n plus 3 plus 15. Okay, so n plus 1 by 2, 6n plus 18. Further you can take 2 as common and it can be cancelled. Okay, so that becomes very simple. So the important thing is, first of all, you have to find out the nth term. After finding out the nth term, do the summation, so you'll be able to get the sum of the sequence. Okay. Similarly, in this sum, we have to find out the sum of this series. So what we do, the first term of the first work that we have to do is to find out the nth term. So 1, 2, 3, the nth term will be n. Then 2, 3, 4, nth term will be 2 plus n minus 1 into 1. That is the common difference. So it is n plus 1. So nth term is n plus 1. Then 5, 6, 7. So 5, 6, 7, the nth term will be 5 plus n minus 1 into d. So it is n plus 4. Okay, you can cross verify it by putting 1 or 2. So if you put 1, you'll be getting 1, 2 and 5. If you put 2, you'll be getting 2, 3 and 6. So that is the correct nth term. Now if you have got nth term, you just have to take the summation to find out the sum, right? First of all, just multiply. Nth term is equal to n square plus n into n plus 4. So it is n cube plus n square plus 4n square plus 4n, that is nth term. So it is n cube plus 5n square plus 4n. So this is what the nth term. Now sum will be sigma n cube plus 5 sigma n square plus 4 sigma n. Okay, so sigma n cube is n plus 1 by 2 whole square plus 5 sigma n square is n plus 1 2n plus 1 by 6 plus 4n plus 1 by 2. Okay, now you just can take n plus 1 by 2 common and simplify it. I'm not doing that for you. You can do it on your own. The major steps were to find out the nth term. Then after finding out the nth term, write down nth term in this way. That is this way. Then you just take the summation. You'll be able to get the sum of the sequence. Right? Now we have the sum, an important one, and there are two ways to do this sum. Okay, I just write it important over here. 3 plus 15 plus 35 plus 63 and so on. Now if you could observe, this 3 is 1 into 3 plus this is 3 into 5 plus 5 into 7 plus 7 into 9 and so on. Right? So we have already done this sort of sum. The only difference is here the final answer is written, right? Instead of 1 into 3, 3 is written. Instead of 3 into 5, 15 is written. But if we can crack this to this, it will be easy for you to solve. Otherwise I'll tell you different method also. So if you are able to crack, then the problem is really very simple. Now 1 3 5 7, the nth term will be 1 plus n minus 1 into d, so that is 2n minus 1. So nth term of 1357 is 2n minus 1, and nth term of 357, that is 3 plus n minus 1 into d, so it is 2n minus 2, so 2n plus 1. Okay, so this is what the nth term of the sequence, right? 2n minus 1 into 2n plus 1. Okay, so I just expand it. It will be 4n square minus 1 because it is a minus b into a plus b format. So nth term will be 4n square minus 1, right? Now sum is equal to summation of this. So 4 sigma n square minus 1 sigma 1. So it is 4n plus 1 2n plus 1 by 6 minus, now sigma 1 is what? N. If you add 1 1 1 n times, you'll be getting n. So do not forget, most of the students, they just forget this sigma 1, they just write 1 over here. So that's it, really wrong. If 1 is added for n times, 1 for 2 times 2, 1 for 3 times 3, so 1 for n times, it will be n, right? So what will be the sum? That is this expression. You can simplify this and find out the final answer, but I'm not going to do it. You can do it on your own. So this is the one way. The second way is, I just write it down. Sum is equal to 3 plus 15 plus 35 plus 63. This is n minus 1 term and this is nth term. Right? Now I just write down the entire sequence once again with, I just leave one step over here. S is equal to 3 plus 15 plus 35 tn minus 1 plus tn. Okay, now what I do, I deduct this from this. So s minus s is 0 is equal to 3 plus 12 plus 35 minus 15 is 20 plus 28. Then this will also deduct, whatever the term is there will be deducted. Then tn minus 1 and minus tn. Okay. Now the next step, see, we're starting from 3 and going till here, right? 3 minus 0 is 3, 15 minus 3 is 12 and up to tn. So in all, from this place to this place, this tn is extra. From this place to this place there are n terms. Okay, and out of these n terms you can see 12, 20, 28 up to here. This sequence is in arithmetic progression. Okay, from this place to this place total n terms are there, but 3 is not there with this sequence because it is not making an arithmetic progression. Here the common difference is 9, but over here the common difference is 8, right? So from this place to this place total number of terms are n. So from this place to this place the total number of terms will be n minus 1. So these are n minus 1 terms. Now we are having 0 at left hand side, so what I do, it is minus Tn, so Tn I shift over here. So Tn is equal to 3 plus 12 plus 20 till n minus 1 terms. Okay, now I know how to find out the sum of it and sum of an arithmetic progression, so I just use the formula directly. It is 3 plus, how many terms are there? N minus 1, so n minus 1 by 2, 2a, so that is 24, plus n minus 1 minus 1, so it is n minus 2 into d. Okay, so it can be cancelled. 3 plus n minus 1 into 12 plus 4n minus 8. So it is 3 plus n minus 1, 4n plus 4. Okay, 4 I can take common. So 3 plus 4 n minus 1 whole square. N minus 1 into n plus 1. Okay, so further it is 3 plus 4 n square minus 1. Or if we simplify, it is 3 plus 4n square minus 4, so it is 4n square minus 1. You might have known that earlier also we got the same nth term when we adopted that other method, that is 1 into 3, 3 into 5. Now we have found out the nth term. This is nothing but the Tn, and Tn is nothing but nth term. So if you found out nth term, you'll be able to find out the sum. You just have to take the summation of this expression. Okay, so this is the other method. If you don't know how to break this up, that is in 1 into 3, 3 into 5, then you can proceed with this method. And if you are able to crack down that 1 into 3, 3 into 5 thing, then it is easy for you to do the sum in 2-3 steps. Okay, so friends, I hope you are able to get the things. In the next session we'll be discussing more problems based on arithmetic geometric progression. Do revise this session and the previous ones. Bye bye.